Good morning, students. This is your physics class. We are going to discuss about angle of repose. We are going to discuss about angle of repose. In the previous class, you have had a discussion about the angle of friction. Now, we are going to speak about angle of repose. In other words, we call it angle of slide or sliding angle or sliding angle. We used to call angle of repose by these names. Angle of slide or sliding angle. What is meant by repose? Repose here refers to a rest, a state of rest. So, if you place an object over an inclined surface up to a particular value of angle of inclination, the object will be in the state of rest. If the angle of inclination is increased beyond that, the object will begin to slide down. The object will begin to slide down. So, repose here refers to a state of rest. So, the object placed over the incline, will not move up to a particular angle. As the value of angle increases, the object will begin to slide down. The angle at which this behavior takes place or this action takes place is called the angle of repose. So, that is said to be a critical state. Before that angle or up to that angle, the object is said to be at rest, and above that angle, the object begins to slide down. So, you consider an inclined surface or an inclined plane, which is making an angle theta with the horizontal. You can see a diagram over here. You consider an inclined surface which makes an angle theta with the horizontal. An object is placed over, an object or block is placed over the inclined surface. We can say this is called the angle of repose. This angle theta is called the angle of repose. This inclined surface is making an angle with the horizontal surface or horizontal plane. And a block or an object is placed over this inclined surface. We can say here the block will remain in the same state as long as the theta value is not increased beyond the angle of repose. Here we can say for smaller angles, the object may not slide. As theta increases, for one particular value of angle theta, as theta increases, for a particular value of angle theta, the object begins to slide. So, the angle of inclination for which the object begins to slide down is called angle of repose. The angle of inclination, this angle of inclination theta for which the object begins to slide down is called angle of repose. We can say here, we can define angle of repose like this. The angle of repose is the angle of the inclined plane with the horizontal. Angle of repose is the angle of the inclined plane with the horizontal, such that the object placed over the inclined plane slides down. The object placed over the inclined plane begins to slide. Object placed over the inclined plane begins to slide. So, angle of repose is defined as the angle made by the inclined plane with the horizontal, such that the object placed over the inclined surface begins to slide. Fine. Let me consider this block, which is acted upon by so many number of forces. As you know very well, the object is acted upon by a downward gravitational force mg, and also the object is acted upon by a normal reactive force provided by the inclined surface. And as the object begins to slide down, it will be experiencing a frictional force, which is Fs maximum. Why am I writing this frictional force as Fs maximum? You would have seen the graph in the previous class that as you increase the angle, the frictional force will remain as such. As you move the object over a surface, the frictional force will remain as such. And at one particular value of external force applied, the static friction becomes maximum. At that point, the object begins to slide. We can say kinetic friction comes into play. So we can say here a particular value of the external application of force at which the static frictional force is maximum, and also right at the same time the kinetic friction comes into play is the state where the frictional force, static frictional force, is overcome by the external force acting on the object or the force acting on the object. So we can say here, I have mentioned this theta as angle of repose, and I told you this theta is the angle made by the inclined plane with respect to the horizontal, so that the object placed over the inclined plane begins to slide down. So it begins to slide down. So the object is attaining a state of motion. So it has to possess kinetic energy. So kinetic friction comes into play. Right at the same time, the static frictional force is maximum. So if you are asked, when the object begins to slide, what is the value of static friction? You must say it is maximum. What is the value of kinetic friction? It is Fk. It remains constant because the object begins to slide or move over with uniform velocity. So kinetic friction is Fk. You can see the graph over here. Fk is the kinetic friction, and the value remains unchanged, remains constant. So we can say here this Fs maximum is the static friction, maximum value of static friction, which is acting on this particular block because the object begins to slide. So the sliding of the object results you this static friction value as a maximum one. Fine. If this angle is theta, I cannot use this force mg directly to speak about the movement of the object. So I have to resolve this mg into its components. So I can resolve the value of mg into its components as horizontal and vertical components. And you can see here, if this angle is theta, the angle between the inclined plane and the horizontal plane is theta, then this angle is also theta. As I told you in the earlier classes, that if a vector is making, actually mg is the gravitational force is a vector quantity. If any vector makes an angle theta with any of the axes, then that component must be taken as cos theta component. So simply I can write this as mg cos theta, and the other component must be mg sin theta. So I can say here There are various forces acting on the block which is placed over the inclined surface. One is the downward gravitational force mg, the normal reactive force n, the static friction value whose value is maximum. Then the components of this mg we have resolved. We have resolved this mg into its components. One is the parallel component to the inclined plane, which is mg sin theta. I can say this is parallel component, and mg cos theta is the perpendicular component to the inclined plane. See, what is the reference here? Inclined plane. So with respect to the inclined plane, mg sin theta is a parallel component acting, mg cos theta is the perpendicular component acting on the block. And you can see here, if this mg sin theta component acts on this block of mass or block of certain mass, you can see here, this mg sin theta tends to move the object or slide down the object along the inclined plane. So it will make the object to move down the inclined plane. This mg sin theta component, which is acting on the block, is made equal to Fs maximum when this theta is at the angle of repose. When this theta is at the angle of repose, this mg sin theta will be made equal to Fs maximum, which means this mg sin theta is now capable of making the object to slide down the inclined plane. Mg sin theta is capable of making the object to slide down the inclined plane. Whereas mg cos theta component is acting in a direction exactly opposite to the normal force. Here you can say mg cos theta component is balanced by the normal reactive force. Mg cos theta component is balanced by the normal reactive force. Normal reactive force, which acts in the upward direction. So I can write here m is equal to mg cos theta. This is equation 1. M, normal reactive force, is equal to mg cos theta. This is equation 1. Also, we can say here the static friction value has attained its maximum. So, as per the relations which you have studied earlier, Fs maximum is equal to mu s into n. Mu s into n. Fs maximum is equal to mu s into n, where mu s is the coefficient of static friction. Mu s is the coefficient of static friction. And n is the normal reactive force. Normal force acting on the mass. Fs maximum is the static friction value, which is maximum. So let me take this equation as equation number 2. Substitute 1 and 2. Substitute 1 and 2. You can substitute 1 and 2. What is this expression? Fs maximum, this is equal to mu s into n. N is mg cos theta, so I can write this as mu s mg cos theta. This is equation number 3. This is equation number 3. This Fs maximum, which is equal to mu s mg cos theta. This is equation number 3. Also, we can write this expression. This friction condition can also satisfy the relation. This friction can also satisfy the relation. The static friction Fs is equal to Fs maximum. Actually, static friction will be acting throughout the motion, throughout the pull provided to the object. When the object begins to slide or move, then right at that point, I told you, the static friction value will become maximum, and right at that point, the kinetic friction comes into play. So the static friction value is Fs maximum, and that has been written as mu s mg cos theta. Fine. And this friction condition also, or this friction also satisfies the condition from the diagram. Also satisfies the condition from the diagram. Condition from the diagram. I can write Fs maximum. Actually, Fs maximum is acting along the left hand side, or otherwise I can take this. I can take this coordinates so that you can understand clearly. This Fs maximum is moving along the negative x direction, and mg sin theta is moving along the positive x direction. So we can say here, or we can write here, Fs maximum is equal to, Fs maximum is also equal to mg sin theta. I can write this as equation number 4. If you just look at the expressions 3 and 4, the left hand sides are the same, so the right hand sides must be equal. Left hand sides are the same, so the right hand side must be equal. I can write it dividing 3 or 4 by 3, dividing 4 by 3, we can write dividing 4 by 3. Dividing 4 by 3, we can write Fs maximum divided by Fs maximum. Actually, both the equations have their left hand sides equal. So this is equal to mg sin theta divided by mu s mg cos theta. So Fs maximum gets cancelled out, you will be left with 1. So mu s mg, or you can even cancel this mg also. Can cancel this mg. Can cancel this mg. So mu s cos theta equals sin theta. So we can write mu s is equal to sin theta divided by cos theta. This is equal to tan theta. So I can write mu s is equal to tan of theta. Mu s is equal to tan of theta. So the coefficient of static friction is equal to the tangent of the angle of repose. Or otherwise, you can state it this way: the tangent of the angle of repose. The tangent of the angle of repose is equal to the coefficient of static friction. Coefficient of static friction. Mu s is equal to tan theta. Also, from angle of friction, you have the relation mu s is equal to tan of theta. The same expression has been obtained for angle of friction also. For angle of friction also, you got the same expression. The coefficient of static friction is equal to the tangent of angle of friction. So, from angle of friction also, you got the expression mu s is equal to tan theta. So, nothing is different in these expressions. Whether it is angle of friction or it is angle of repose, the expressions are the same. Mu s is equal to tan theta, which means the tangent of the angle of repose is equal to the coefficient of static friction. Fine. Now, my question is, what is the difference between coefficient of static friction, means coefficient of angle of friction and angle of repose? Here I am saying this is angle of repose, and this theta is angle of friction. I can say here angle of repose and angle of friction are one and the same. Angle of repose and angle of friction, are the same, but the difference is that angle of repose is used to explain the sliding movement of objects on an inclined surface. So angle of repose is for inclined surfaces. Angle of repose is for inclined surfaces. Angle of friction is for any surface. Angle of friction is for any surface. This makes the difference. So angle of repose is for inclined surfaces and angle of friction is for any surface. So what are you trying to define here is that if an object is placed over an inclined surface, the object will begin to slide only when the angle made by the inclined surface with respect to the horizontal is equal to the angle of repose. Is equal to the angle of repose. You can calculate the angle of repose when you know the value of coefficient of static friction between the two surfaces. So mu s is equal to tan theta. If I need to know tan theta, then we can write here theta. I can mark it as theta suffix r, angle of repose. This is equal to tan inverse of mu s. So if I know the value of coefficient of static friction, I can easily calculate the value of angle of repose. So angle of repose here explains you when an object will begin to slide down an inclined surface. Moreover, if you look at the expression, there is no term related to mass. In this expression, we have no term related to mass. So I can say here theta r, angle of repose. Angle of repose is independent of mass. This is not in a text. You can make a note of it. You can just make a note of it. Angle of repose is independent of mass. Also, what are the factors to which the angle of repose depends upon? Angle of repose depends upon one, angle of repose depends upon one, the material and the nature of the surface in contact. It depends upon the nature of the material, or in other words, I can say it depends upon the material. And two, it depends upon the nature of the surfaces in contact. Nature of the surfaces in contact. So this is an important idea which you should know. The angle of repose is independent of mass. That's the first thing. Second thing is that the angle of repose depends upon the material and the nature of the surfaces in contact. Harder or rough the surfaces, the angle of repose will be greater. Smooth the surfaces, the angle of repose is lesser. Even any object which is placed over a smooth surface, when provided a smaller value of angle of inclination, will begin to slide down. When the same surface is a rough surface, the angle of repose will be greater. This you can easily understand by making a simple experiment. You just take a textbook in your hand, the cover of the textbook, if it is to be a smooth polished surface as your textbook is given, when you place a coin on the surface, for a particular value of angle of repose, the coin will begin to slide down. If you do the same with a textbook whose surface is very hard or rough, then you have to incline or you have to increase the angle of inclination further. Means the angle of repose must be increased further in order to make the coin to slide down the inclined surface. Now to make the coin to slide down the inclined surface. So it all depends upon the nature of the surface in contact. It also depends upon the nature of the material placed. And also this angle of repose ranges from 0 to 90 degree. This you should know. The angle of repose ranges from 0 degree to 90 degree. 0 degree to 90 degree. The value of angle of repose ranges from 0 degree to 90 degree. So the angle of repose, the inclined surface may be exactly parallel to the horizontal surface. This is the horizontal surface, this is the inclined surface. It may be parallel, in this case theta is 0, and the surface, inclined surface may be perpendicular to the horizontal surface. Here it is 90 degree, but it lies between 0 and 90. We used to say it is not exactly 0, not exactly 90. Instead, I can say the angle of repose ranges from or lies between 0 to 90. That will give you a clear picture over here. So the angle of repose lies between the angle of repose lies between 0 degree to 90 degree. This is all about angle of repose. Idea is quite simple. So angle of repose is nothing but the angle made by the inclined surface with respect to the horizontal surface such that the object placed over it begins to slide down. We are calculating at what angle the object will begin to slide. That has been determined with the expression mu s is equal to tan of theta. There theta equals tan inverse of mu s, where mu s is the coefficient of static friction. Mu s is the coefficient of static friction. And finally, we have concluded that the angle of repose is independent of mass, and another one, the angle of repose depends upon the material and also depends upon the nature of the surfaces in contact. And the third one, the angle of repose lies between 0 to 90 degree. We shall now solve a simple example problem which is given in your textbook. This is given in your textbook. The block of mass M slides down the plane, inclined at an angle of 60 degree. Example 320. The block of mass M slides down the plane. The block of mass slides down the plane, inclined at an angle of 60 degree. So, this is the inclined surface. A block of mass M slides down the inclined plane. Block of mass M slides down the inclined plane. It started sliding, which means it affects its kinetic friction. It is inclined at an angle of 60 degree. It started sliding in the sense this angle is called angle of repose. With an acceleration A equals G by 2, it is moving. Its acceleration A equals G by 2. What is the coefficient of kinetic friction? You are asked to calculate Fk, coefficient of kinetic friction. As I told you, this will be experiencing a downward gravitational force mg. When resolved into its components, we can write this as mg sin theta and this one as mg cos theta. And then here the object is experiencing a kinetic friction. The normal reactive force acts along this direction. This is the diagram. If this is 60 degree, this angle is also 60 degree. This angle is also 60 degree. So kinetic friction comes to play as the object begins to move on the surface, or the block begins to move on the surface. The forces acting on the masses have been represented in the diagram here. One is the downward gravitational force mg, normal reactive force m, the force of kinetic friction Fk, which acts along the surface, and the components components of mg. One is mg sin theta acts parallel to the inclined surface, and mg cos theta acts perpendicular to the inclined surface. Now we are taking the coordinate axis over here because it is required. So xy is the coordinate axis. There is no need to take coordinate axis like this. It is already, it has been given in the conditions that if you are speaking about the inclined surface, there you can directly take the coordinate axis according to the inclined surface, according to the angle of inclination. So xy is the coordinate axis. Along the x direction, I'm just considering it as a free body diagram, and then I am solving it. Along the x direction, the various forces acting are mg sin theta, because mg sin theta is pulling the block in the downward direction. Mg sin theta I cap minus of Fk I cap is equal to ma I cap. Here the object slides downwards along the positive x direction. Comparing the components, I can write mg sin theta minus of Fk is equal to ma as theta equals 60 degree, a equals given g by 2. We can write mg sin 60 minus of Fk is equal to mg divided by 2. Sin 60 is root 3 by 2. So I can write root 3 by 2 mg minus of fk is equal to mg divided by 2, from which we can calculate what is the value of coefficient of kinetic friction. So I can write fk is equal to root 3 by 2 mg minus of mg divided by 2. mg by 2 can be taken out. We'll have root 3 minus 1. So fk is equal to mg by 2 root 3 minus 1. mg by 2 root 3 minus of 1. Now, the object accelerates along the positive x direction. There is no acceleration taking place in the vertical direction, means along the y direction, because mg cos theta balances the normal reactive force. mg cos theta balances the normal reactive force. So I can write here mg cos theta is balanced by n, normal reactive force. So I can write here n is equal to mg cos of theta, which is mg cos 60. Cos 60 is 1 by 2. So simply I can write n is equal to mg divided by 2. n is equal to mg divided by 2. We are speaking about the kinetic friction value here, kinetic friction here. So the kinetic friction can be represented as fk equals mu k into m. We need to calculate the coefficient of kinetic friction mu k. We need to calculate this mu k. So fk equals mu k into m. So mu k is equal to fk, f suffix k divided by m. What is fk here? What is fk here? We already had the expression mg by 2 into root 3 minus 1 divided by the normal reactive force has been calculated as mg divided by 2. This gets cancelled out. So simply mu k is equal to root 3 minus 1. This is otherwise represented as 1.732 minus 1. This is 0.732. So coefficient of kinetic friction is equal to 0.732, which is root 3 minus of 1. So this is how the problem goes. So if you are asked to calculate the kinetic friction value, coefficient of kinetic friction value, you can find out what is the value of kinetic friction, what is the value of normal reactive force. If you divide the kinetic friction by normal reactive force, you can calculate fk, because fk equals mu k into m. We shall now see the applications of angle of repose. The applications of angle of repose. We shall see now the applications of angle of repose. Applications of angle of repose. If we just look at the examples here, we can see antilens. Antilens. Antilens அப்படின்னா புலி நரின்னு இருக்கும். You might have seen this in villages. Most of the landscapes, you might have seen this kind of small cone-shaped tunnels, which is inclined. This is how the surfaces will be. So this is how the sand trap has been created by the antilens. So antilens will make sand traps to catch the insects. As the insects approaches the edge of the inclined surface, they begin to slide down, because the angle of inclination of this surface is equal to the angle of repose. The angle of inclination of this inclined surface with respect to the horizontal is equal to the angle of repose. So if it is at the angle of repose, what happens? What happens? Any insect which comes near the sand trap, any insect, it will be conical in shape. Any insect which is coming at the edge of the sand trap, it will be sliding down. where the antennas will hide themselves at the apex of the cone. Antennas will be hiding themselves at the apex of the cone. So they can easily catch the insects. They can easily catch the insects. So antennas make sand traps in such a way that when an insect enters the edge of the trap, it starts to slide down towards the bottom of the trap where the antennas hide itself. Here, as I told you, the angle of inclination is equal to angle of repose. You can just look at the diagram given in your textbook, picture given in your textbook. So you can understand it easily. Then you might have seen the sliding boards in parks where children used to slide down, right? A sliding board is there. Children used to slide down the sliding board. The angle of inclination of the sliding board is made equal to the angle of repose, so that any object or any child who is made to sit on the surface of the sliding board will begin to slide down towards the bottom. Will begin to slide down towards the bottom. Because the reason is quite simple. The angle of inclination of the sliding board with respect to the horizontal is equal to the angle of repose. Is equal to the angle of repose. So, not only children, any object which is placed over the sliding board will be sliding down. If the angle of inclination, if the angle of inclination is less than the angle of repose, we cannot slide down. If the angle of inclination is greater than the angle of repose, if the angle of theta is increased, I can write angle of inclination is greater than angle of repose. What will happen? The child will slide down the sliding board, but they will be hitting the ground or they will be reaching the bottom with greater speeds. Reaching the bottom with greater speeds. So that they will get hurt. They will get hurt. So, in order to avoid this, the sliding boards must be kept exactly at the value of angle of repose. The angle of inclination of the sliding board must be exactly at the value of angle of repose, so that the children can slide themselves over the sliding board and enjoy. Right? These are some of the applications of angle of repose which we have seen. And I told you the activity to perform with your textbook. So the angle of inclination of the cover of your textbook at which the coin placed over it begins to slide is called the angle of repose. You can calculate, you can measure the value of that angle theta. Take the tangent of that angle. Take the tangent of the angle theta, from which we can calculate the coefficient of static friction between the surface of the cover and the coin. You can calculate the coefficient of the static friction between the cover and the coin. The same can be repeated with other objects like eraser or any sliding object which is placed over the textbook. So, at the point of sliding, you can write tan of theta s is equal to mu s. Tan of theta s is equal to mu s. At the point of sliding, tan theta s is equal to mu s. Tan theta s is equal to mu s. To measure the coefficient of kinetic friction, initially you have placed the cover of the textbook like this. This is equal to angle of repose. The coin placed over it started sliding down. In order to measure the coefficient of kinetic friction, after or when the coin begins to slide down, reduce the angle theta. Reduce the angle theta by lowering the cover of the textbook, so that the coin will begin to move with uniform velocity. Coin will begin to move with uniform velocity. The coin starts sliding down with uniform velocity. Now measure the angle from which we can calculate the coefficient of kinetic friction. Now we can measure the angle. If you are decreasing the value of angle, actually this is angle of repose. This is the angle measured for kinetic friction. So theta k gives you the angle for kinetic friction. Simply we can write here tan of theta k is equal to mu k. Tan of theta k is equal to mu k. One thing you can understand is that theta k is less than theta s. Theta k is less than theta s. This also explains that mu k is less than mu s. Mu k is less than mu s. Coefficient of kinetic friction is less than coefficient of static friction. So when the object is placed over an inclined surface, the object will begin to slide down when the angle of inclination is equal to angle of repose. We can say that as the sliding angle theta suffix s. So as the object starts moving, you just lower the angle of inclination so that the object placed over the inclined surface moves with the uniform velocity. So you just note down that angle. We call that angle as theta k, angle of kinetic friction, from which we can calculate tan of theta k is equal to mu k. So from these expressions, you can understand that theta k is less than theta s. The angle for kinetic friction is less than the angle for static friction. Theta k is less than theta s, which indicates that mu k is less than mu s. So this once again explains you about the relation that coefficient of kinetic friction is less than coefficient of static friction. So finally, I would like to conclude here. About angle of repose. Finally, I would like to conclude about angle of repose here. If you look at the diagram, once again, you can see here, an object is placed over an inclined surface. This inclined surface is making an angle theta with the horizontal. For smaller angles, the object may not slide. As theta increases, for a particular value of angle theta, the object will begin to slide. Hence, this is called the angle of repose. Hence, we can define the angle made by the inclined surface with respect to the horizontal, such that the object placed over it begins to slide is called the angle of repose. We have to define like that. And we have to study about the forces acting on the block placed over the inclined surface. We saw various forces: normal reactive force, mg in the downward direction, Fs maximum along the negative x direction, and this mg has been resolved into mg sin theta and mg cos theta components. Mg sin theta is the parallel component to the inclined surface, mg cos theta is the perpendicular component to the inclined surface, and then mg cos theta is balanced with normal reactive force, from which I am getting the expression 1. M is equal to mg cos theta. M is equal to mg cos theta. And then from the relation connecting static friction, maximum value of static friction and coefficient of static friction, I can write Fs maximum is equal to mu s n, where n is the normal force. So Fs is equal to Fs maximum, and this is equal to mu s mg cos theta. This friction also satisfies the condition from the diagram. Fs maximum is equal to mg sin theta. You can look at the diagram here. Fs maximum is equal to mg sin theta. Two are equal. Then dividing equation 4 by 3, you will get mu s equals sin theta by cos theta, which is equal to tan theta. So mu s equals tan theta, where this theta is called angle of repose. The tangent of the angle of repose is equal to the coefficient of static friction. Also, we can see from angle of friction, mu s is equal to tan theta. Same relation exists for angle of friction as well as angle of repose. Thus, we can say angle of repose and angle of friction are one and the same. But only difference is that the angle of repose is meant for inclined surfaces and the angle of friction is meant for any surface. That is very important. And the angle of repose is independent of mass. The angle of repose depends upon the material as well as the nature of the surfaces in contact. Also, you can say the angle of repose lies between the angles 0 and 90 degree. Right? We can call this angle of repose as sliding angle or angle of slide. This will mean you a lot. So repose here refers to a state of rest. So up to that angle, the object is at rest. And then beyond that angle, it begins to slide. So that critical state or the critical angle has been referred as angle of repose. This is all about the idea of what we had today. This is the discussion we made, angle of repose. You just kindly go through it. This is a very simple idea, but very important, right? We shall see in the next class. Thank you. You can go for a break now.